Now we want to be able to add and subtract them. In order to add and subtract fractions, you need to have common denominators. So notice in the first problem, the common denominator is going to be what? 8. So you just need to multiply the top and bottom by 4. And we get 4 over 8 plus 3 over 8. And that makes our 7 over 8. Let's do one more together, then we'll flip to the back side. Letter D. What's going to be the common denominator between 10 and 15? 10 and 15.
35.
Close?
30.
30. Now,
Always skip to that.
oh yeah, I'm sorry. So, yep, so Chuck was looking at this one. If I have 10 and 15, would everybody agree that 150 can be a common denominator? But it's not the least common multiple. So the least common multiple here is going to be 30. I'm going to multiply top and bottom by 2, top and bottom by 3. So you can see in this situation that we do get a 27 over 30. And we are going to minus then 4 over 30. And so we get 23 over 30. We good? All right. So let's flip to the other side, okay? And what we want to do now is we want to see how we can add and subtract fractions that may look a little bit different. They may have elements that are not common denominators. They may have algebraic expressions in them. So in example A, I have 2 and 3. The common denominator will be what? 6. So I'm going to multiply the top and bottom here by 2. And the other side, I'm going to multiply the top and bottom by 3. Do you guys not have this? Yep, just backside, yep. And so I need to distribute the 3 through, and I get a 3x minus 9 over 6. And I get a plus 4x minus 14 over 6. (3x plus 4x is 7x, and negative 9 and negative 14 make negative 23. What's different about letter B? There's really 2 things that are different there. The denominators are the same, and instead of addition, we have subtraction. When you have subtraction, make sure you're distributing that subtraction sign all the way through. So the denominators are already the same, so you could write it as a 7x plus 3 minus the quantity 3x minus 5 all over 4. So the denominators are the same. You can put it all over one denominator. We need to distribute that subtraction sign. So it's going to be 7x minus 3x, which is 4x. And then is it going to be 3 minus 5 or 3 plus 5? Plus. 3 plus 5, because you distribute the subtraction sign to the negative, and I end up with plus 8 all over 4. Am I done?
Oh.
What can I factor out of the top? Of 4 times x plus 2 all over 4 on the bottom, and those reduce to x plus 2. Change it up a little bit. Now we see a 2x and a 3. Talk to the person next to you. What do you think the common denominator is in this situation? What do you think the common denominator is here? Go ahead and talk. I heard a bunch of people shout it right away. What do you got? 6 and x. So in order to make this a 6x, I need to multiply the top and bottom by 3. And in order to make the other one a 6x, I multiply the top and bottom by what?
2x.
2x. So we have a 15x minus 3 on top. On the bottom, we have a 6x. Minus, again, you're going to multiply the 2x to each of these pieces. It's going to be an 8x squared and a plus 6x. All over 6x. My denominator is now 6x. As I write my numerator, I like to gather my terms as the highest degree first. The highest degree is x squared, okay, x squared. So is this going to be a positive 8x squared or a negative 8x squared? It is a negative 8x squared. So that one's gone. Now I look to combine my x's. Is it 15x minus 6x or is it 15x plus 6x?
Minus.
Minus. And so we get a 9x and then we have a minus 3 on the end. And in that situation, there's nothing that factors or cancels. So that part is done. I'd like to do problem 4A together, and then we'll do the sets for 5, and we'll give you guys some time to work. But talk to the person next to you. What do you think you should do to start letter 4A? What do you think you should do for 4A? Go ahead. Come up with something.
Most that's a different thing. I think I'm talking about because I know what I'm talking about.
So notice that this is an x and this is an x minus 1. Can I subtract 1 from the top and the bottom to make them the same? Suppose you had 5 over 7 plus 1 over 6. In that situation, can you just subtract 1 from the 6 and the 5 in order to make them the same?
No.
No, that doesn't work. So we can't just subtract 1. Sometimes people go to that as an option. If it was a 7 and a 6, you would have to multiply both sides by 7 and 6. So here we're going to multiply top and bottom by x. And here we're going to multiply top and bottom by an x minus 1. So my new denominator is x times x minus 1. The numerator is x minus 1 times x plus 1 plus x times x, which is x squared. As you look to work this out, you really need to take x minus 1 times x plus 1. Let's multiply that out. I have an x times an x is x squared. I have an x times 1 is x. I have a negative 1 times x is negative x. I have a negative 1 times 1 is negative 1. And then we have that plus x squared on the end. And that all sits over x times x minus 1. Notice in this situation that the x and the negative x do cancel. I forgot about that plus x squared, excuse me. And then x squared and x squared make 2x squared. And we'll do one more problem together. We'll do 5A. Common denominator. Talk to the person next to you. What do you think is the common denominator? Take about 20 seconds. What do you think is the common denominator? Go ahead. If you're able to factor the denominator, that can be to your benefit to see what the true common denominator should be. Notice in this situation, I factored x squared minus 9 to be an x plus 3 times an x minus 3. This one already has an x minus 3, so I only need to multiply the top and bottom by what? X plus 3. So I don't need to do anything to the left side. I only need to deal with the right side. And so we have a 4x minus 3 minus the 2x minus 3 times the x plus 3 all over our new denominator, which is x minus 3 times x plus 3. In order to simplify this, I'm going to need to combine anything together in the numerator that I can. So I'm going to have to multiply this out. Okay? I start with a 4x minus 3. And I'm going to subtract everything that comes out from multiplying. And as we multiply this out, we get a 2x squared to start. And then we get a plus 6x. And then we get a minus 3x. And we get a minus 9. All over x minus 3 times x plus 3. The key here is to make sure you're handling your subtraction sign like you should. I'm going to start with my x squareds. Is it a positive 2x squared or a negative 2x squared? Negative 2x squared, that's gone. And then let's look at our x's. We have a 6x minus 3x is 3x, okay? And then it's 4x minus that 3x, which is just 1x. So my x's are gone. And now I have negative 3 minus a negative 9. Negative 3 minus a negative 9. And so we get positive 6. And there we have it. Okay. So adding and subtracting fractions within rational expressions, that can be a challenging piece. So we'll take our time with it. Please open up your homework. As you are adding and subtracting these rational expressions, okay, we have simply just the front page, After that, we go to simplifying complex fractions and then solving rational equations. That gets a little bit more challenging, So please make sure that you're, keeping up with your homework and ready for this, okay? All right, you guys have the rest of the time to work.